Okay, so in this video, we are looking at reducing balance loans. And this is where we start getting into the more life applicable section of this particular course. Now, mainly what we're going to be doing in this video is finding the total amount to be paid on a loan. And we're going to figure this out by taking our loan payment, which we have here highlighted in green. This is basically our monthly payment that we are making on the loan. Because as we've talked about before, if the bank gives you a sum of money, some principal, you are going to have to pay that back. And you pay that back with interest as well. And the interest changes based on the type of loan payment you're making, the size of your repayments, as well as the number of repayments you have to make, which is this thing I have highlighted in yellow. So we're just going to jump straight into a question, and we're mainly working with this formula up here, but we're going to be pulling in a lot of other concepts that we've learned previously in this course. So we have a table down here showing the monthly repayments. Let me actually underline that because that's a key part here for a reducing balance loan. We want to calculate the amount of interest to be paid. So notice I've underlined interest because you may look at this formula and go, sweet, cool, let me just apply this. But what we're finding with this formula is the total amount to be paid with the principal including the interest. We talked about this earlier in this course. And we have a loan of $200,000 over 13 years. So what this table basically tells us is the loan payments, or these monthly repayments on this particular loan based on a term, which we have here, so how long this loan is for, as well as the amount of the loan. So we want to use this table to find what our actual monthly repayment is going to be. So I'm going to look at the key bits that I've underlined in my question. So I have $200,000, which I have here, and I have 13 years. So if I follow these two parts on my grid, I get to this number here where they both line up. So this means that, I'm going to actually write this down, our monthly repayment, what we are paying every month on this loan, is going to be $2,856. This is our first part. Now we want to find the interest, but before we can even get to that, we need to find the total amount that's got to get paid. So we have $2,856 every month. I'm actually even going to write this down here. This amount is getting paid each month for 13 years. So, first of all, let's find out how much. If we have a monthly repayment of this, we can find our yearly repayment by multiplying this by 12, because there are 12 months in a year. That's going to be 2,856 times 12. So we're using things that we've done in rates ages ago, right? Once we have this yearly repayment, we want to find out how much for 13 years. So we're going to take our yearly repayment. This is for 1 year. If we want to find 13 years, we have to multiply this amount that I've underlined the entire thing by 13 again. So we can say our total to be paid equals 2,856 times 12 times 13. Now, let's actually look at how this relates to the formula I actually wrote up here, because you guys might be looking at this going, well, why are we timesing three things together? This guy over here is our loan payment. I'm going to color coordinate this in the same way. This guy is our loan payment, what we are paying every month. This particular thing here 12 times 13 is our total repayments, number of repayments. So I'm actually going to write this down. This is our loan repayment. This is our number of repayments. So 12 times 13, that's because we're making 12 repayments every year. And this is happening for 13 years. So eventually this will simplify once we times 12 by 13. You can even do that earlier. But to find the amount to be paid, we need to take our loan repayment and then calculate the total number of repayments. And we'll, more often than not, if these are monthly repayments, be multiplying by this 12 over here because there are 12 months in 1 year. Now, once we do that, we get a total amount we have to repay of $445,536 to the nearest dollar. So this is the total to be paid. Now remember, the total to be paid, I'm just going to write this as TTBP. That takes into account our principal, the thing we are borrowing, which is the $200,000, plus the interest. So, remember here, we talked about this before, the interest is the difference between the total to be paid and the principal. So we can find our interest by doing 445,536 minus our 200,000, the amount that we actually borrowed. So let me just shift this thing down. That's not working, that's all right. So let me write this here. Our interest equals this amount, 445,536 minus 200,000. And that's going to give us 245,536. Remember, when we're doing this, using this particular formula, it gives us the total to be paid. Now it's up to us to recall that the interest gets added to the principal to get to our total amount to be paid. This is where the previous things we learned are sort of carrying over. Okay, let's do one more question here. This table shows the monthly repayments for each $1,000 borrowed. Molly is planning to borrow $280,000 to buy a house at 8% per annum over a period of 20 years. So, once again, in part A, this is asking what is Molly's monthly payment on this loan. So, what we're going to do, first of all, we want to use this same bit that we did in the first part. We have a period of the loan and we have an interest rate. It's a different table, but it means the same thing. So we're going to remember that we have 20 years and this is at 8% per annum. So this is going to be my $8.36. Now, this is the slightly tricky bit when we work through questions like this. This table gives us the monthly repayments for every $1,000 borrowed. So for each $1,000 borrowed, we are paying $8.36 on that. We are borrowing $280,000. So we need to figure out, first of all, how many times 1,000 goes into 280,000, and that thing is what we're going to multiply by our $8.36. So this just shows us how many times, if we find $8.36 for every 1,000, once we find out how many times 1,000 goes into 280,000, we can just multiply that by $8.36 to find what the monthly repayment is going to be on that higher amount of money. So I'll just do it up here. 280,000 divided by 1,000 gives you 280. So to find the monthly payment, $8.36 is the monthly payment for $1,000, for every $1,000, but we're trying to find the monthly payment for $280,000. So we're going to take 836 and times this by 280. And what that gives us is $2,340.80. This is what we are paying. Let me actually highlight it. This is what we're paying on a $280,000 loan. The $8.36 tells us what we are paying on a $1,000 loan. So that's why we're dividing this thing by 1,000 and then timesing this 280 by our $8.36. Part B says, how much would Molly pay in total to repay this loan? So we're going to recall that to find our total to be paid, we're going to take our loan repayment and multiply this by our number of repayments. Okay, so we have our loan repayment. We found that in part A. We have our $2,340.80, and now we want to find the number of repayments. So remember, these are monthly repayments. So we're going to be making 12 of them every year for 20 years, as written in the question. So we're going to take this number here, times it by 12 to find our yearly payment, then times that by 20 to find out our total payment after 20 years. And this thing is going to give us $561,792 to be repaid. Okay, so part C says, how much would Molly save if she repaid the loan over 15 years? So, as with most things that we've talked about earlier in this series, if we repay our loan in a shorter amount of time, it's pretty likely that we're going to be paying less interest, and then as a byproduct of that, a less total amount in general. So this question is just asking us to compare this. Now, before we even do anything, we have 15 years here. So we need to go back to our table. So this tells us, if I just rub out these previous bits, I'm instead now looking at 15 years. Now it doesn't mention anything about a different interest rate, so we're just going to assume that the interest rate is the same. Remember, the question should explicitly tell you if the interest rate changes. Right now, all we're changing is the period of the loan. The interest stays the same. And we see that this means that it is a $9.56 monthly payment for every $1,000 on this loan. So what we're going to do a very, very similar thing to what we did in the first part. Just this bit's a little bit less scaffolded because now we're used to it. We want to first find our monthly repayment. And we do that by taking our $9.56 and multiplying this by the 280. So it's the same thing that we did up here. We're finding how many times 1,000 goes into 280 and then dividing it through. It goes into 280,000, sorry. And then multiplying finally this 956 by the 280. This now gives us a new monthly repayment of 267,680, which kind of makes sense that we're getting a higher monthly repayment because we're trying to pay off this loan in 5 years shorter time. So it makes sense that these repayments now get higher. So we're going to do the exact same thing we did before then. We have our total amount to get repaid equals the loan repayment times the number of repayments. So our loan repayment is $2,676.80, and our number of repayments, the thing that's changing here is we still have to times this by 12 because there's 12 monthly repayments every year, but we're multiplying this by 15 now because we're now trying to pay off the loan in 15 years. Once we multiply this all through, we're going to get $481,824. Now, you may be wanting to just stop here. You go, well, I found what it is. Let's go back to our question. It's asking us how much would Molly save. So we need to compare this to the amount for repaying the loan in 20 years that we found in part B. So we're finding how much she saved. So we're finding the difference between this guy here, $561,792, and this amount that we found here. So our final bit here, we're going to write our amount saved equals to 561,792 minus 481,824. Okay, subtracting these, finally we get our amount saved as $79,968.